Hi, Math Stars. Before we dive into today's lesson, I just need to review with you some algebra skills that you need to do the calculus for today. So the first one, you see this problem, e to the ln 7 plus x to the fourth. First thing we're going to do there is we're going to separate this into two different exponential expressions, both with the base of e. So we have e to the ln 7 and then e to the x to the fourth. We're allowed to do that. It's just one of our exponent rules. Usually we do that same exponent rule in the opposite direction. So we might do x squared times x to the fifth, and we would add those exponents together to get x to the seventh. This is the same exponent rule, just going backwards. We're taking a sum in the exponent and splitting it into two different powers of e. So when we go back to this problem, we have e to the ln 7 and e to the x to the fourth. So this first expression just simplifies to 7, and then we have e to the x to the fourth. Okay, over here on the right, we have y to the negative 1 equals x plus 5. To get rid of that power of negative 1, we're going to raise both sides to the negative 1 power. So a power to a power, you multiply the powers, and when we multiply the powers on the y, we just get y to the first power. You can leave the answer like x plus 5 to the negative 1 power with the parentheses, or you can rewrite it as 1 over x plus 5. You just can't separate that into two fractions. It has to stay together. So either of these possibilities are sufficient for your answer. Okay, lastly, you learned this at the beginning of the year in Algebra 2, so I know it's been a really long time. But when you solve an absolute value equation, you separate it into two equations. You make one equation x minus 1 equals 6, and the other one is x minus 1 equals the opposite of the right-hand side, or negative 6. Then you just solve x minus 1 is equal to 7. X equals 7, and then x is equal to negative 5. Normally, we would have to plug those back in the original problem and make sure they're not extraneous solutions, but that's not going to apply to what we're doing today. Okay, Math Stars, let's go ahead and learn something about separable differential equations. So y'all have solved differential equations before. An example of a differential equation is where you're given that a derivative dy dx is, say, equal to x cubed. And how would we solve for y? Well, we would just integrate both sides. A separable differential equation is a little bit more complicated. Looking a little bit higher up on the page, we see that dy dx is equal to some function of y times some function of x. So there's a function of y and a function of x either multiplied together or divided in the problem. So let's look down at example 1. Find a solution, y, to the differential equation dy dx equals 3x squared over e to the 2y, satisfying f of 0 equals 1/2. Okay, so before we can integrate, we have to do step 1 at the top, which is separate the variables. The only way you can separate the variables is by multiplication or division. So we're going to multiply the e to the 2y to bring it to the other side. The only way you can separate variables is by multiplying or dividing. So I'm going to multiply the e to the 2y to bring it to the left. I'm going to then multiply the dx to bring it to the other side. I don't want a dx left in the denominator. I want to multiply it so it's not the denominator of a fraction. We have done no integrals with the dx in the denominator. Every integral we've done, the dx has been in the numerator or just off to the side past the integrand. Okay, so now that we have separated the variables, we're going to integrate both sides. So we're going to go ahead and stick an integral on both sides. So on the left-hand side, we have to do some u substitution. So u is equal to 2y. It's been a long time, hasn't it? du is equal to 2 dy. So as you know, we have to multiply in our integral by a 2. Let me get orange. Okay, so let's multiply in here by 2, which means we're going to multiply in front of the integral by a 1/2. Okay, so then let's go ahead and substitute. So we're going to have 1/2 the integral of e to the u du equal to, now on the right hand side we don't need to do substitution, so we can go ahead and just integrate using the power rule. X cubed plus c. So we're adding 1 to the power. When you divide by the new power, the 3's cancel out. Okay, so take a look at what we have now. We can go ahead and integrate the left-hand side now. And when we do that, we're going to get 1/2 e to the u. But I'm going to go ahead and plug the u back in, which is 2y. We don't do a plus c on both sides. We're only going to do a plus c on the right. And I'll tell you why in a minute. Okay, so let's take a look. We did step 2. Let's go back up here and check. Step 3, if there's an initial condition, substitute and solve for c. They did give us an initial condition. So this is our input, that's our x value we're plugging in, and this is our output or our y value. So let's plug that in. So we're going to have 1/2 e to the 2 times 1/2 is equal to 0 cubed plus c. Okay, so simplifying that, we get c is equal to just 1/2 e. Okay, go down to step 4. Use the c you found and solve for f of x. So let's go back to, so what we're going to do is we're going to go back over here to the right-hand side, the left-hand side, and we're going to plug that c we found into this original equation after we did our integrating. So we are going to have 1/2 e to the 2y equals x cubed plus 1/2 e. Okay, we just need to solve for y now. So we have to get rid of 3 things, the 1/2, the e, and the 2. So we're going to multiply everything by 2 first to get rid of the 1/2. So we're going to end up with e to the 2y equals 2x cubed plus e. Okay, so next, to get rid of the e, we're going to apply ln to both sides. So applying ln on the left, the e cancels out. We're just left with 2y is equal to, and then the right-hand side we have ln, and we have 2x cubed plus e all in the integrand. Or I'm sorry, all in the argument. That's all in the argument of ln. Okay, and then lastly, to get the y by itself, we're multiplying by 1/2. So we have y is equal to 1/2 ln of 2x cubed plus e. That's our final answer. And when we go back and look at the initial condition they gave us, so the initial condition they gave us was that f of 0 is equal to 1/2. So if we plug in a 0 here for x, so I'm looking on the bottom right-hand side, plugging in a 0 there for x, we have y is equal to 1/2 ln of 0 plus e. So, but ln of e is just 1, so y is equal to 1/2. So we do get, it does satisfy the initial condition when we plug a 0 back into our answer. Okay, let's take a look at a couple more examples. Number 2 says, if dy dx equals 2y squared, and if y equals -1 when x equals 2, then when x equals 2, y equals question mark. So let's go ahead and rewrite the problem here so that we can go ahead and separate the variables. So eventually, remember in the last problem we did, we eventually solved for y. So I'm only going to bring the y squared to the other side. I'm not going to bring the 2 over because eventually I have to get the y by itself. And so I don't want to bring over more stuff with the y that I just have to move back to the other side later. So y squared dy is equal to 2 dx. Remember, we're multiplying and dividing to get to separate the variables. So I'm going to integrate that left-hand side. So remember, that's the same as y to the -2 power. So if I integrate y to the -2 dy, that's going to give me y to the -1 divide by -1. Well, if I'm dividing by -1, I can just bring that to the front. So let's integrate the 2 dx. the integral of 2 dx is 2x, and then we're going to do our plus c on the right only. Okay, we separated the variables. We integrated both sides. Now we're going to plug in. So this is the information we're plugging in to find c. So we're going to have negative 1 to the negative 1 power is equal to 2 times 1 plus c. Okay. Negative 1 to the negative 1 power, well, that just flips the number over, takes its reciprocal. The reciprocal of negative 1 is still negative 1, but multiplying by the negative in front, that turns it into a positive 1. So c comes out to be negative 1. So what do we do with that? Well, that's going to get plugged in over here into our expression we got when we integrated. So we have negative y to the negative 1 is equal to 2x minus 1. So now we're solving for y. We have to get rid of two things. We have to get rid of the negative in front and the exponent. So when we solve, we do PEMDAS backwards. So I'm going to get rid of that negative in front. I'm doing the multiplying and dividing first before I do the exponent because I'm doing PEMDAS backwards. So dividing by that negative. And then lastly, to get rid of that power of negative 1, I'm raising both sides to the negative 1 power. And so y is going to equal negative 2x plus 1 to the negative 1 power. Okay, so we found the solution to the differential equation, but we didn't answer the question. So the question says when x is 2, what does y equal? So we're going to find y of 2 by inputting a 2 here. So that's going to give us negative 4 plus 1 to the negative 1 power. And that's just negative 3 to the negative 1 power, which is just negative 1/3. Okay, so we answered the question completely. Okay, next one. Find y equals f of x. So in other words, they're saying find the solution to the differential equation. And the differential equation is dy dx equals 2xy with the initial condition f of 0 equals negative 5. So how do we solve this? Well, first thing we're going to do is separate those variables. So I'm going to leave the dy on the left and bring the y over. So we're only separating variables by multiplying or dividing. So to bring that y over to the left, I divide to bring it. So the 2x is going to remain on the right, and I multiply to bring the dx to the other side. Okay, so why don't you pause the video and see if you can do the next few steps. Integrate both sides. Plug in and find c. Try to solve your solution for y. Then you can resume it if you get stuck, or just resume the video to check your answer. So go ahead and pause it right now, please. Okay, hopefully you're really successful. Let's see. So we're going to integrate both sides. So integrating 1 over y, we get ln of the absolute value of y. And on the right, let's integrate, we get x squared plus c. So let's plug in the initial condition. So over here, we have an x and a y that we're plugging in. So plugging in a negative 5 for y, that equals 0 plus c. So normally we can't take ln of a negative number, but there's an absolute value there, so that's fine. So ln of 5 is equal to our c value. Okay, what do we do with that c? Well, that gets plugged in right here. So we have ln of the absolute value of y is equal to x squared plus ln 5. Okay, we need to get y by itself, so I have to get rid of that ln next. So I'm going to give both sides a base of e. And so we get absolute value of y is equal to, and now at the very beginning of the lesson, I taught you that you could separate these two into something like e to the x squared times e to the ln 5. So this guy here, that just simplifies to 5, and that becomes our coefficient. So we have the absolute value of y is equal to 5e to the x squared. Okay, also at the beginning of the lesson, we talked about how when we solve an absolute value equation, we do the positive and negative of the right-hand side. So we have the positive of 5e to the x squared and the negative of 5e to the x squared. So how do we determine which one we're going to have as our answer? Well, we have to go back and look at this initial condition we started with. So right here, I'm boxing. This initial condition we started with, when we input a 0 to our function, we should get an output of -5. Well, in order to get an output of -5, we have to choose the negative coefficient. That way, when I input a 0, e to the 0 power is 1. And so I get a 1 times -5, so that does give me -5. All right, Math Stars, go ahead and give a really good try to the homework assignment that I'm posting also. I know this is like super tough, like having to learn calculus from afar, but I know you can do it. So go ahead and post any questions you have or any concerns, or just go ahead and email me if that's better for you. Okay, take care.